All right. Last week, we had started talking about arithmetic and geometric sequences, and we were using the recursive and the explicit formulas to find terms in that sequence and other information about the sequence itself. This week, we're going to start talking about how to actually find the sum of those sequences. So, in other words, when we start adding up an arithmetic or a geometric series, because remember, series is when you add up a sequence. When they ask us a question like that, add up however many terms of this sequence, then you have to have a way to do it because some problems will be easier because you can just write out the terms and find the sum that way. But then some of them, they might ask you to find the sum of the first 500 terms in that sequence. And there is no way that you can write out all 500 terms and be able to add them up in a timely fashion. And so that's actually what we're talking about this week is how do you find the sum of different types of sequences. And so since we've been concentrating on arithmetic and geometric, that's what we're working with. All right. So the first thing is sum, remember, is another name for add. So it's wanting you to add up the terms in the sequence. And there is some notation that goes with that. So sum, when you find the sum of a sequence, they're going to use an S for sum, and then there's going to be a little subscript of an N. And usually this will be a number. But whenever they have it written like that, that actually means that you are finding the sum. In other words, you're adding them up of however many terms in that sequence. So it's the sum of n terms in that sequence. Okay. So today we're going to concentrate on what are called finite sequences. So finite means that it's a sequence that isn't going to keep going. So they might say, find the sum of the first 5 terms in this sequence. That means you just have to either write out the first 5 terms and add them up, or you can use one of these formulas that we're going to talk about today. So finite means that it's not going to keep going. You're actually finding the sum of a certain number of terms. And so I know that may be a little confusing, but when you see the notes for tomorrow, it'll make a whole lot more sense. Okay. So if they ask us to find the sum of an arithmetic or a geometric series, there are 2 formulas that if it's one of the harder problems and you can't write the sequence out, there are 2 formulas that you can use, okay? But the first thing you have to do is figure out, is it arithmetic or geometric? So remember, arithmetic, you're adding a constant number to go from one term to the next. Geometric, you're multiplying by a constant number to go from one term to the next, all right? So if it turns out being arithmetic, the sum formula that you will come to know and love, there's actually 2 ways that I've seen it written. One way that I typically will write it as is you take n, which is however many terms you're adding up, times your first term plus your a sub n term. Now the a sub n term is the last term that you end up adding in to that sequence, and then you take all of that and you divide it by 2. All right, so that's one way that it's written. The other way that sometimes you'll see it written, and it means the exact same thing, is like this. Instead of putting all of it over 2, they'll just take this n and put it over 2, and then multiply it times the rest of it. And it actually is the same thing. It's just 2 different ways of writing it. So you can pick whichever way you like it and do it that way. So that's if it's arithmetic. This will help you add up however many terms they're wanting you to add up. Okay, you just have to know these pieces of information. So then if you find out that it's geometric, the sum formula, or the formula that will add up a certain number of terms in a geometric series, you have to take the first term times 1 minus your common ratio, and then you bring it to the power of n, which is however many terms you're adding up, and then you divide 1 minus your common ratio. Okay, so what we're going to do today is just practice using those formulas to add up a sequence. Okay, so in number 1, it says find the designated sum of each series. Before you can actually use a formula or do anything like that, you have to figure out what kind of sequence is it. So add a little note to yourself. You have to figure out what type of sequence it is first. Because that'll actually tell you which formula to use. Okay, so for this first sequence, we've got negative 13 minus 11 minus 9 minus 7. So find the pattern. What are we doing to go from one term to the next? If I kind of observe what's going on here, I'll notice that I'm actually adding 2. Now, if I didn't realize that, remember, to figure out if it's arithmetic, you take one of its terms and you subtract the one right before it. So, like, I could take negative 11 minus negative 13, and 2 negatives make a positive. So when I do that, I get 2, a positive 2. And so I could check it. If I'm adding 2, like if I add negative 11 plus 2, I will get negative 9. And then if I add 2 again, I get negative 7. So that means, because we're adding 2 each time, that means that this is an arithmetic sequence. And so if I have to add up the first however many terms of that sequence, I'm going to use the arithmetic formula. Okay, so I'm just going to take that formula down here and I'm going to copy it down. So we would be using S sub n equals, and you can choose either one. Like I said, this is the one that I typically use just because I got used to using it that way. Or using this formula. And I'm going to plug it in. Okay, so notice this means we are finding the sum of the first 11 terms of that sequence. Okay, so that's what goes here. We're finding the sum of the first 11 terms. So n would actually be 11. Okay, so when I take this and I plug it in, my n is 11, so that's what goes there. This is my first term. Well, if I look at my series there, negative 13 is the first number that I'm going to be adding in to the sum. So that's what goes for my a sub 1 term. And then I have to add that to whatever the last term is that I would add in. And this is where it gets interesting, because notice they have the little dot, 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 but we don't know what that last term is that we'll add in. And it's technically, because we're adding the first 11 terms up, it's technically going to be whatever the 11th term is in that sequence. And so you have a choice. You could write it out until you get to the 11th term, or you could go to the side and you could actually use the formula that we dealt with last week to find what that term is. And so a sub n, that formula, the explicit formula that we used several times last week, you can just copy that down so you can look it up in your notes, or you can just memorize it. But that was the formula for an arithmetic sequence. So now we're looking for, what is that last term? Well, that would be the 11th term. So we're looking for the 11th term. And then we just plug it in. So my first term is negative 13 plus my n, well, we're looking for the 11th term, so my n would be 11. And then my common difference, remember, is the number that's added each time, so it would be 2. And then I could just type that into my handy dandy calculator. And when I do that, I think I ended up getting 7. So that 11th term that I would be adding in, or that would be the last term I would add in, would be 7. So that's what goes for this. Okay. And then all of this is divided by 2. And so now that I have all of my information, I'll just plug that in my calculator just how it looks. And if you have Desmos, you can plug it in just how it looks. And then you should get negative 33. Okay, so what that means is if you actually wrote this sequence out all the way to the 11th term in that sequence, if you added up all of those terms, all the first term all the way to the 11th term, you would end up getting a sum of negative 33. Okay, remember this is not a term that's in the sequence, it's actually what you get when you add the terms up. Okay, it's what you get when you add the first 11 terms. All right, so we're going to do one more of these so that you have one more example, kind of like with the way the question's phrased, and then we'll do some that ask the question a little bit different way. All right, so the next one, you are having to find the sum of the first 7 terms. Okay, so you're looking for the formula that'll help you do that. And now this would, I'll be honest, this would be one where, because you only have to add up the first 7 terms, this would be one where it's actually going to be easier probably if you just write out the first 7 terms and then add them. Okay, so don't forget about that. That sometimes will make your life easier. Okay, but since I'm trying to tell you how to use the formulas and show you that, I'm going to help you with the formula. All right, so just like the last one, we've got to figure out what type of sequence it is. So I'm going to try to find the pattern here. Am I adding a constant number or am I multiplying by a constant number? And so if I kind of observe my numbers here, it kind of looks like, because we're going from 4 to 8, 8 to 16, 16 to 32, it kind of looks like we're maybe multiplying by 2. And so I'm going to check it. 4 times 2 gives me 8. 8 times 2 gives me 16. 16 times 2 gives me 32. So because we are multiplying by a constant number, that actually means that this is a geometric sequence. So when I have to add up the terms in a geometric sequence, I'm going to use this formula. Okay, so you can just copy that formula down, or you can just look at it and kind of plug it in from just looking at it, but I'll copy it down since this is the first one that we've done like this. Okay, and then I'm going to see if I can find all of my information. So we are finding the sum of the first 7 terms. So my 7 goes where the n is. Okay, remember this is however many terms are adding up. And then I got to know my first term. Well, the first term that I'm going to add up into that would be 4. So that's what goes there. And then it's times 1 minus. Now, as a piece of advice, with this one especially because it has the exponent with it, always get in the habit of putting the common ratio, which is what R is, in parentheses there. If you do not, and you type it in your calculator, sometimes your calculator will not do it correctly because it's gonna, like if this happened to be a negative number, it won't include the negative, okay, when it does the little exponent part, all right? So my common ratio, remember, is whatever number I'm multiplying by, so that would be 2. That's what goes there. And then it's to the power of n. Remember, n is however many times you're adding up. So it'd be to the 7th power. And then all of that is over 1 minus your common ratio, which is 2. And so now down here, it doesn't necessarily have to be in parentheses just because you're just combining them. But if you want to go ahead, like if you want to get in the habit of doing that all the time, it won't hurt. Okay. Then now that this is one where we actually knew all of our information. So we didn't have to go to the side and do work like we did here. Okay. So since we knew all of our information, all I have to do is type that in my calculator. And when I type that in, I end up getting 508. So if I actually wrote out all 7 terms from 4 to whatever the 7th term is, and I added them up, I'd end up getting 508 as the sum. Okay, so the next problem, just kind of getting more practice in, it says we have to find the sum, in other words, add up the first 13 terms in the following series. And then it gives us the series. So because we're adding up the first 13 terms, that means that n is 13. And so the notation with that would be we're finding the sum of the first 13 terms. So it would be S sub 13. Okay. So again, we got to figure out what kind of sequence it is. This one, all right, let's see. Am I adding a constant number. So to go from 1 to -6, it's kind of going into the negative. So to make that happen, I would have to subtract something. So if I didn't know what that was, I could take -6 minus 1, take a term minus the one before it, and that would mean I am subtracting 7. So I could check it. Am I subtracting 7 each time? All right. Well, if I take -6 minus 7, would that give me 36? And notice it won't. So that means that it's not arithmetic because we're not adding or subtracting a constant number. So now I'm going to think to myself, is it geometric? So I can do the same kind of thing. I could take -6 divided by the term before it, which is 1. And notice I get -6. So I'm going to check, am I multiplying by -6? Does it have a common ratio of -6? Well, if I take -6 times -6, would I get positive 36? And yes, I will. And then if I take 36 times -6 again, that'll give me the -216. So because I am multiplying by a constant number, that means that this one's geometric, okay? So I'm going to use the geometric formula, kind of like the one that we did up here, and I'm going to plug in my information. So if you look at this equation where I had read it before, the first term, well, that would be 1 times 1 minus, well, whatever my common ratio was, which in this case is -6. Remember, getting the habit putting in the parentheses. And then it's to the exponent of however many terms I'm adding up. So that would be, I'm adding up 13 of those terms. And then all of that is over 1 minus my common ratio, which is -6. And then I have all my information. So all I have to do is type that in my calculator. And then for this one, I end up with a doozy of an answer, which sometimes with geometric sequences, it does end up giving you a huge answer. So it's okay. It gives me I'm just going to write it down, 1865, 813, 431. So this would technically be 1,865,813,431. So if I added up the first 13 terms, if I actually wrote that sequence out and then added up the first 13 terms, that would be what it would add to be. Okay, so we're going to do one more problem and then I'll let you guys work on the homework with it. So it says with this one, find the sum of the first 35 terms of this series. All right, so we're finding this S sub 35. All right, what's the pattern? What am I doing to go from one term to the next? Here, it looks like I'm subtracting 3. So let's see. If I take -2 minus 3, I get -5. -5 minus 3, I get -8. -8 minus 3, I get -11. So that means I'm subtracting 3. So this means that it's arithmetic. So I'm actually going to use the arithmetic equation. So I'm going to be using this one. All right. So look at it while I go over it. Okay. So if I plug in, it's going to be n. So n is however many times I'm adding in. So it'd be n times my first term, which -2 is my first term. All right. So that's what goes there. Plus whatever that last term is that I would add in, which would technically be the 35th term. And notice we don't know what that is. So that means just like that other problem we did, we're going to have to go to the side and find what is the 35th term. Okay. So I'm actually going to go ahead and do that. So take back to that formula and I'll write it down again. The explicit formula, the formula that you use to find a term in an arithmetic sequence is that one. So we plug in. My first term is -2 plus, we're looking for the 35th term. So this is the position of whatever term you're dealing with. And then it's times the common difference, which I was subtracting 3. So it would be -3. Okay, and then I just type it in the calculator. And so the 35th term, that last term that I would add in, would end up being -104. So that's what goes there. And then don't forget the rest of that formula, all of that should be over 2. So once you kind of figure out all your information, just a matter matter of plugging it in and then plug it in your calculator. So if I plug this in, what this formula does, remember, is it adds up the first 35 terms of this sequence, right? So if I added up the first 33 terms, when I typed that in, I ended up getting negative 1,855. So make sure that you ask questions. Make sure that if you need to meet with me, that you log into one of the Zoom sessions or just email me. Have a good day.